So hello, welcome to my talk on zombies and the science of brains. So as Yomi mentioned, my name is Dr. Jacquelyn Omelian. I'm a professor of practice here in the psychology department at UNL, and one of my passions is zombies, and another passion of mine is brains. So today we're going to talk about those two things together. So to start off with, if we're going to talk about zombies, we need to understand what is a zombie, right? So when I say zombie, you all picture something, probably something that looks like this, right? So this is an example from George Romero's classic zombie film from the 1960s, Night of the Living Dead. And that was really one of the first big zombie movies to hit popular culture, and our love affair with zombies has just sort of continued from there. So we've seen zombies throughout a number of different movie franchises, increasingly popular in various television programs and into video games. So whether we're talking cute or creepy, zombies are very, very popular, right? So the question is, what is a zombie and why do they act like that? Now, I want to clarify one thing when I talk about zombies. I'm talking about the stumbling, decrepit, falling apart kind of zombie, not the portrayal that you may have seen in some popular media where they're super fast, hyper ability, because to quote Simon Pegg, who wrote Shaun of the Dead, death is not an energy drink, okay? Zombies are going to have some very characteristic symptoms, and they're going to be less mobile than humans. So if we're going to talk about zombies, then we need to talk about how do you kill a zombie, right? So how do you kill a zombie? Shoot it in the head, right? So you have to destroy the brain. So essentially, when we're talking about zombies, we're talking about an animated creature that's coming after you, right? It's coming after humans. It wants to consume human flesh, and the way to defeat it is to destroy the brain. So really what we're talking about when we're talking about destroying zombies or killing zombies is damaging or destroying the central nervous system. So in our vocabulary, the central nervous system is going to be the brain and the spinal cord. So in order to kill a zombie, you have to destroy the brain or the spinal cord. Okay, so now everyone is prepared should zombies attack. You know how to kill them. So let's take a look at that in a little bit more detail. So when we're talking about the central nervous system, we're talking about the brain and the spinal cord, but we're going to look into specifically the brain. So here's an image of a brain, right? So we're taking a top-down view. And one of the first things we see with the brain is that it's divided into two sections. And these are known as the left and right hemisphere. So both hemispheres, left and right, are made up of a number of other structures referred to as lobes. So the brain has these two halves, right and left, and then these associated lobes. So I'm going to give you guys all a model of the brain that you can take with you tonight. So to do this, what you're going to do is go ahead, make a fist with your thumb on the outside, like this, and then cross your hands like this. So you've now created your very own model of your brain. So let's look through some of these lobes on this brain model. So the first two fingers, your pinky and ring fingers, those are going to make up what's known as the frontal lobe of the brain. So those are the areas associated with higher cognitive function, thinking, planning. So you can remember that by thinking pinky, thinky, okay? Front part of the brain, frontal lobe. The next part of the brain is going to be your middle and ring fingers, and that's going to be the parietal lobe. Okay, so this is the area of the brain that's going to be associated with motor function and sensory information. So getting information into the brain and moving our bodies afterwards. So sensory and motor in the parietal lobe. Okay? At the back of the brain, notice you have where your fists are closed, sort of looks like two eyes. That's the occipital lobe. The occipital lobe is going to be responsible for vision and visual processing. Then finally, where your thumb shows on either side is the temporal lobe. The temporal lobe is going to be responsible for a number of different things, but for our purposes, we're really going to focus on its integration with language and speech. Okay? So now you have your 4 lobes of the brain, and notice that when you made that model, you crossed your hands. That's because the brain has what's known as contralateral control of the body. So the left hemisphere is primarily responsible for the right side of the body, and the right hemisphere is primarily responsible for the left side of the body. So when we're looking at zombie symptoms, if we're looking at deficits on the left side, we know that the right side of the brain is probably where that damage lies. Okay, so model of the brain. So we know this is what we have to destroy if we're going to take down a zombie. But let's look and see what might happen in this normally functioning brain to create a zombie model. So we said that one of the characteristic things that zombies do is stumble through life, right? So they are stumbling, they're very stiff-legged, stiff-jointed, they have very stooped posture, and when they do move their appendages, it's not well coordinated. So characteristic zombie symptom is issues with motor control. Let's look and see what might explain some of those difficulties getting around. So we know from our model of the brain that the motor cortex up in the parietal lobe is associated with movement. We see areas associated with motor control, including the motor cortex, and then some deeper brain areas known as the basal ganglia and the cerebellum, this area back here, all associated with motor control. And in patients who have not zombieism, but motor disorder issues, we see these same brain areas being affected. So for example, consuming alcohol can influence and interrupt functioning of the cerebellum and lead to some very zombie-like stumbling around. So these are good candidate areas for explaining what's happening with zombies. The other issue that we see with zombies is they don't seem able to coordinate their movements to their environment, suggesting that there's likely some damage to the sensory cortex as well. So still up in that parietal lobe, they're likely having some difficulty orienting and engaging with their environment. And then finally, remember we said that the brain controls the opposite side of the body. So when we have damage to one side of the brain, the opposite side of the body is what's going to be implicated. So if we have a zombie who's stumbling along, dragging his left leg, it's likely that the brain area that's damaged is part of the motor cortex in the right hemisphere. All right, so let's look at another zombie symptom. So what is it that zombies like to eat? Brains, right? So zombies like to eat human flesh. Specifically, what zombies like to eat best is you. So why do we see this preference for human flesh? Specifically, when we look at what's happening with zombies, why do we go from a loving relationship to lunch? So one of the things that might be happening with zombies is that they lose the ability to recognize friends and family. So if we look at our brain model again, we're going to be looking at areas of the occipital lobe, so that back area of the brain, to see are there issues with visual processing. One of the disorders that we see in the real world that sort of looks like some of this loss of recognition is known as prosopagnosia, or face blindness. And this is a real disorder that happens in individuals where they are unable to recognize others by their facial features. Now, these people don't automatically assume that their neighbor is lunch, but they may not be able to depict or to recognize another individual based on facial features. They have to use other defining characteristics like hairstyle, clothing, tone of voice, etc. So maybe the reason that zombies go from friendly to so hungry is that they stop seeing other humans as friends and start seeing them as a tasty snack. So this is a particularly interesting characteristic of both zombies and individuals with prosopagnosia, because in typical individuals, we are very good at facial processing. Humans are highly evolved to detect facial features. We're a very social species, and we are so good at seeing faces that we tend to see them even in instances where they're not really there. So this idea that we have specific brain areas associated with the ability to detect faces suggests that the loss of this ability is something unique. So we can take another look at this, right? So I'll give you a test of your own facial recognition abilities. So here's an image of famous musician Adele, right? So very quickly you see this image and you recognize this as a person, right? Even if you don't know exactly who it is, you see this face and you recognize it as the image of a human. Similarly, if I flip the image upside down, you still recognize it as a person, right? Still readily recognizable, even though I flipped the image. So much so that your mind doesn't notice the errors in that image. So in this first image, only her face is inverted, her mouth and eyes are left at proper orientation, and we don't notice it until we flip things back. And things become much more recognizable as something being amiss, right? This is because when we look at faces, we preferentially look at the eyes and mouth to determine, is this image that I'm seeing a friendly face? So maybe zombies have just lost this ability entirely. All right, so what do zombies sound like? Everybody give me your best zombie call. Good, right? So what I'm not hearing there is a lot of really good vocabulary, right? Zombies are typically portrayed as having very minimal vocabulary or language skills, right? They're moaning, they're groaning, maybe they're calling out for brains, but they don't have a lot more vocabulary than that. So this distinct loss of language ability is a key characteristic of a zombie. So let's look at how this might be happening. When we're talking about language, we're talking about areas associated with the temporal lobe. Specifically, we're talking about a couple of areas that have been found to be particularly linked to language. So the first of these is Wernicke's area, located towards the back of the temporal lobe. And this area is especially related to language processing, so our ability to understand language. If we damage this area, we see a loss in this ability. Similarly, we have another area known as Broca's area, which is particularly responsible for language production. So this is our ability to speak. If we damage Broca's area, we see what's known as Broca's aphasia, or a lack of language production ability. So what we're likely seeing in zombies is a combination of damage to both of these areas, known as global aphasia. So a loss of both the ability to produce language and a loss of the ability to understand what's being spoken to them. This is why your cries for help are largely ignored by the attacking zombie horde. All right, so one of the other characteristics, one of the most defining characteristics of zombies is their incredible aggression, right? They are really mad at the world. So in order to understand what's happening, we can look at the HPA axis. So we can look at what's happening. How do we handle stress and aggression in a typically functioning human? One of the ways that we do this is by regulating hormones from the brain through the body through the HPA axis, or the hypothalamic pituitary adrenal axis. This is the same system that's activated during issues of fight or flight in typical humans. So when you're suddenly confronted by a bear or a charging zombie, you have the option of running away or trying to fight. Maybe what's happening in zombies is that fight or flight system is broken and they're just in fight mode all the time. That would explain this intense aggression that we see. All right, so now we've explained some of the possible reasoning behind zombie symptoms. And we know that zombies aren't real, right? Right? Well, let's look at some examples of how we could see some disturbingly zombie-like behavior possibly actually occurring. So if we take the idea that zombieism is caused by some sort of disorder that causes these changes to the brain areas we've talked about, we have a couple of candidate areas or types of disorders that could lead to this type of damage. So the first is the issue of a zombie parasite, which might sound ridiculous, except that it's a little bit more science than science fiction than you might have realized. So if we look at Toxoplasma gondii, Toxoplasma is a parasitic infection that has a very specific life cycle. So Toxoplasma can only sexually reproduce in the intestines of cats. So while some people find long walks on the beach and, Tuscan villas romantic, for Toxoplasma gondii, it's all about the intestines of the cat. So what that means is that this parasite has evolved a life cycle aimed at getting it to the intestines of a cat. So what we see with Toxoplasma gondii is that the parasite infects a cat, it reproduces, and the cat sheds some of the parasite. That shedding of the parasite can then infect a number of different hosts. Its target host are small prey animals, including rodents and small birds. But it can also spread to larger mammals. It can come into contact and be spread through water and plant fibers. And it can be passed on through fecal matter of infected animals. All of these are ways that Toxoplasma can infect humans. But we said that these infections to mammals and large mammals and humans aren't really the aim of the parasite. It wants to get back into a new cat in order to be able to reproduce. So we see Toxoplasma infection in humans in about 30% of humans across the world. But again, its driving life cycle is to get into a cat. So let's see how it does that. The way that Toxoplasma gondii infects and reinfects new cats is by infecting small prey animals, including mice. So mice are naturally afraid of cats. If you take a mouse that has never seen a cat before, introduce it to the smell of cat urine, it will have a fear response. They have an innate fear to cats because cats are predators. However, a mouse infected with toxoplasmosis loses that fear. So the parasitic infection changes the animal's behavior, causing it to lose its innate fear of cats and actually become attracted to the smell, and thus end up as lunch, leading the parasite into the cat's intestine. So we have a parasite changing behavior following infection, leading to the death of the host, which is a little bit zombie-ish. right? So now remember, we said that 30% of humans are also infected with Toxoplasma. So what does that say about Toxoplasma in humans? Does this mean that humans are unnaturally attracted to cats? Fortunately, the answer is no. It doesn't seem like the parasitic infection changes human behavior. Although there's still research being done in this area, it doesn't look like we see behavioral effects in humans. So far, crazy cat lady, just a crazy cat lady. Not a form of zombieism. All right, so that's parasites. Let's look at some potential other causes, including a virus. So zombie virus has been by far the most popularly publicized type of zombie infection in the media or in media representations. So we're going to look at an example of a real-life virus that sort of mimics what we see in zombies, and that's rabies. So rabies is a real-life virus. It is an extremely dangerous, lethal virus. An infection has very serious consequences, but we can use it as a model of what a zombie virus might look like. So animals infected with rabies undergo inflammation of the brain. So we have a virus that's affecting the central nervous system. What's more is that virus is transmitted from one species to another via infected saliva through a bite wound. So saliva from an infected individual entering the bloodstream of another individual. That's how the infection spreads. Sounds kind of zombie-ish. What's even more interesting is that this virus changes the behavior of infected hosts. So at a physiological level, it induces some changes, including increased saliva, causing animals to have this characteristic foaming at the mouth that we see with rabies. It also causes the animals to become increasingly aggressive. So we have increased saliva, increased aggression, and then the final behavioral change that we see is known as hydrophobia, or a fear of water. So individuals infected with rabies produce more saliva, won't drink water to remove that saliva or dilute it, and are increasingly aggressive. All ways that the virus increases the likelihood of transmission through an infected bite. Sort of like what we see with zombies, right? So this idea of changes to both behavior and physiology aimed at increasing exposure to the virus. All right, and then finally, our final potential mechanism for zombieism to be passed along is through a zombie fungus. So this has been popularized in the video game The Last of Us, as well as some other media representations, and it's based on an actual virus, or an actual fungus, that exists, known as Cordyceps. And Cordyceps are a type of fungal that spread by infecting living hosts. So Cordyceps release spores that can infect animals, including certain types of ants. Those infected animals have their nervous system essentially taken over, so the virus prompts them to move to an elevated location, and then the animal dies, and the cordyceps grows out of the corpse. That cordyceps then goes on to release spores into the surrounding environment, which has the potential to infect an entire ant colony in a very short order. So we have a spread of this fungus happening very, very quickly to an entire population. There are also thousands of types of cordyceps, and each one has a specific preferential species that it infects. Fortunately, there are not any types of cordyceps that interact with humans and take over our nervous system, at least not yet. All right, so we talked about how zombies could occur, right? We talked about the ways that zombie as a disorder could be passed along. We talked about some of the content areas or some of the candidate areas in the nervous system that could be underlying some zombie symptoms. And I do want to take a minute to reference Do Zombies Dream of Undead Sheep, which is a book put forth by a couple of cognitive neuroscientists that really drove this talk and sort of inspired my work both for this talk and for the honors course that I teach in the fall on the neuroscience of zombies. So I do want to give a shout out to those authors. All right, questions about zombies? Yeah.
Isn't there like a zombie-like disease in deer that's like been a thing recently? And like, how is that? Is that like a bacteria, virus, fungus?
Yeah, that's a great question. I believe it's a bacteria that's been infecting animals and causing some decay, like, so not true zombie, not animated corpse, but causing some decay and associated behavioral changes. Yeah, good question.
Before we have any more questions, since we are recording this talk, we do want to get the questions through the microphone. So if you raise your hand, I'll bring you a microphone. No, nobody has questions.
Questions?
Yes. Okay, you first.
So what like inspired you to be like so interested in zombies?
Yeah, that's a great question. So I read this book a couple of years ago in, I believe, 2015, and I thought that it was a really cool take on the idea of intro neuroscience. And so as someone who teaches neuroscience type classes and psychology courses, I'm always looking for new ways to introduce that information in a sort of a fun and inviting way. And the nice thing with zombies is everyone knows what a zombie is. They've pretty much infiltrated our culture, if not our real world. So it's a good model to be able to talk about, here's a behavior that we're all familiar with, here's a disorder that we've all seen in the movies, and let's look at some of the brain areas associated with it. Great question, thank you.
So what about Creutzfeldt-Jacobs disease, or I think it's called mad cow disease? How does that tie in with this, and like how does that affect the brain?
Yeah, that's a great question. So mad cow disease is an example of a prion disorder, which is a type of infection that changes the way that cells make proteins, and it can cause cell death, particularly in areas associated with the brain. So when we see cell death in the central nervous system, we're not able to recover from that kind of damage. We have very poor neuroplasticity and neurogenesis in the brain. So when those cells die off, we're not able to recover, and that's where we see things like neurodegenerative disorders, including different types of prion disorders. Yeah.
Based off what you based off what you know about how the brain would be affected by zombies, is there any depiction of zombies in like pieces of works that you think would be the most realistic if it were to happen?
Yeah, that's a great question. So I will say that The Walking Dead has been really lauded by a number of different scientific communities as being a really good depiction, not only of what zombies would look like, but what the spread of a zombie infection would look like. So the time scale, the way that people react, the eventual demise of a civilized society, all of that is a pretty good, if somewhat dark, take on what a zombie infection would look like. Yeah, absolutely. That said, I will say Shaun of the Dead, my favorite personal depiction of zombies, just because it is extremely entertaining.
Do you think zombies are able to think?
think zombies, it's a great question. So I think it depends a little bit on what type of zombie we're talking. So we've seen in examples like World War Z where we have zombies who not only seem to think, but they work in teams and they collaborate and they have a lot more sort of social skills than if we say look at Night of the Living Dead where they're really just falling apart animated corpses. So it would really depend on the brain areas that are affected and what type of underlying cause is leading to that zombieism. So if we look at something like a parasite, where it's really taking over the entire central nervous system, probably much less likely that they're going to have those cognitive reasoning skills. If we have damage to the frontal lobe, again, we're going to lose some of those cognitive abilities, and they're going to be much more driven by those base instincts of hunger, fear, anger, and chasing. Yeah, good.
How common are I think it's a disorder or an illness, but you said where people are not allowed, able to see faces or differentiate between faces. How common is that?
It's a great question. So I don't know the exact specific or the specific amount of prosopagnosia that we see in society. One of the issues with disorders like prosopagnosia is that they tend to be underreported. People go a long time without realizing they ever have it because they just assume the way they see the world is the same way everybody else sees the world. So when we have issues like prosopagnosia, sometimes people don't find out that they have it until they're into adulthood or much older.
So in movies and television shows, there's always like a pursuit of a cure. Mm-hmm. So is there any cures for all of the different situations you've talked about today?
Yeah, so good question. So with some of the issues, so like the fungal infection, there isn't a cure per se because it's not impacting humans. It hasn't really been the focus of research. Rabies does not have a cure. However, we have vaccines that we can give to infected individuals, and if the vaccine is delivered prior to the onset of symptoms, it is an effective treatment. With toxoplasmosis, we don't have a treatment, again, because the underlying infection doesn't seem to be causing massive issues. Yeah. Although I believe they are working on vaccinations for toxoplasmosis.
So do you think that there'd ever be a drug that can produce those same results? Because I remember there was a case in Florida once where the guy smoked bath salts and then he went crazy. They couldn't take him out with guns or tasers and he ate a guy's face.
Yes, so there are instances like that where we see people exhibit zombie-like symptoms, right? So one of the most famous cases of real-life zombies are what are known as Haitian zombies, which is in parts of Haiti in traditional culture, there are neurotoxins that have been given to individuals that induce essentially a death-like state. So incredibly reduced respiration and heart rate. So these individuals appear dead to the point where the society will throw a funeral for them, engage in sort of a celebration of death, and then when another drug is given that counteracts that neurotoxin, these individuals come back to life. And it's been used in some religious ceremonies and things as a way to create what's known as a Haitian zombie. Unfortunately, it's been abused to the point where these individuals who are returned to life are often used as slave labor and highly mistreated in that culture. But it is possible to induce that sort of death-like state and then recovery.
I guess I don't know how long it was, like how long ago it was, but when the Ebola virus was viral, why did so many people compare it, like call it like the zombie disease or like virus?
Yeah, that's a good question. I think part of it was related to the spread and how quickly and poorly contained much of the spread of the virus was. There's also some popular culture references where Ebola was popularized in a couple of movies as sort of a zombie-like infection. Yeah, great questions.
So I was already familiar with Toxoplasma, and I'm curious if there are other lesser known things similar that affect other animals and make them less afraid of predators.
So Toxoplasma is certainly the most well-researched type of parasitic infection. There may be others, but I think Toxoplasma is really the one that we've used as sort of a candidate model for an infection that dramatically changes evolutionarily based behavior.
All right, if there are no more questions, can we please give another round of applause for our speaker?